Exaptation is when a trait evolves for A but ends up repurposed for B. For example, feathers evolved for insulation but later ended up used for flight. My main beef with the scientific consensus regarding this process is this. This exaptation process is very suspiciously serendipitous. For example, mushrooms evolve a slug and insect confusant, an effective repellent for their immediate pests. But then, 70 million years later, Earth narrowly dodges a second planet cracking rock. Here, let me connect the dots. Yeah, it's like the mushrooms are saying the cows went that way. Take us with you. And also, by the way, why are you so stupid? Let's take care of that for you. Okay, here we go. We're going to think until our heads grow like balloons. And that's exactly what happened. Our ancestors' brains grew in size and complexity so fast that we've practically set a record for radical and rapid mutations. It's very rare for an organ to evolve that much in that period of time. And psilocybin helped us do it, even though it evolved to repel insects. This process where the mushroom creates a chemical for one thing, like protecting itself from insects, but then later on, it ends up using that chemical for another thing, like guiding primates along a game trail and helping them kill large animals and getting them to carry the spore-laden mushrooms along the game trail that is called exaptation, which is a tricky word. It's not pronounced exact. It has a P, not a C, exaptation. That's when an organism evolves a trait, a quality, a body part, a defense, a chemical pathway. An organism evolves something, and that thing that the organism evolved ends up being used for something else. Like a good example is feathers. The ancestors of birds originally evolved feathers as simply insulation. Later, they became repurposed for flight and changes were made. They became lighter, more specifically suited to the purpose. But in a way, they were already purpose-built for flight because the feather is such an extremely adaptable structure. Life always favors adaptability. DNA has a fetish for adaptability. It can't let it go. It's obsessed with it. And when I anthropomorphize DNA like this, talk about it like a human, I'm referring to its choices in an evolutionary context. How it mutates and which mutations are successful in that picture, given a number of choices. Evolution always chooses the most adaptable one. Psilocybin mushrooms is such an interesting example. I like the idea of mycelium as the Earth's nervous system. And if that is the case, then it's not crazy to think it might be capable of, if not foresight, which is obviously adaptability within projected future context, then at least preference for adaptability within its contextual environment, things it's already experienced. And asteroid impacts would fall under the category of things the mycelial colony experienced. I'm not surprised it took 70 million years to crack that nut, but it got there, didn't it? Well, actually, that's just psilocybin. It took a lot longer than that if you look at it as how long did it take mushrooms to evolve a defense against asteroids? Because for a lot longer than 70 million years, mycelial colonies have been for spreading out through massive parts of forests and essentially emulating nervous systems and doing an immense amount of calculation, probably doing some version of thinking and feeling things. I can't say for sure, but are very comparable to your nervous system, so why not? So these have been thriving on Earth for a very long time. Oregon, Russia, the Amazon, if they're healthy, forests are all basically growing out of ancient mycelial networks, and historically, occasionally, large parts of these complex mycelial networks have been annihilated by asteroids. So, if mycelium is Earth's nervous SE.
So, if mycelium is Earth's nervous system,
So, if mycelium is Earth's nervous system, this is kind of like having a stroke. So this chemical, which originally, mushrooms evolved a chemical pathway to produce psilocybin in order to protect themselves from insects and slugs, but now they're using it to help higher primates put spears in large mammals, and in exchange, those primates are helping the mushrooms follow the large mammals on the game trails so that they can grow in their feces and in other places along the human path where they might find favorable growing conditions. So because the fungi favored the slug repellent that was most adaptable to solve the problems that might arise in the future, because DNA has this preference for adaptability in its manifestations and their effective uses and purposes. 70 million years later, Earth is now able to prevent a second planet cracking rock impact. We have telescopes, computers, guided missiles, a nuclear arsenal. We have organizations dedicated to this purpose. Would all of that still happen without psilocybin? Maybe. But it didn't. It happened with psilocybin in a world full of game trails that are peppered with psilocybin-rich, colorful mushrooms, and they did guide our ancestors, and they did improve their vision and make the animals easier to kill, and they did improve their intelligence, their imagination, redirect nutrition to the development of their brains, and for all, the inclusion of psilocybin in their diet caused an explosion of imagination and libido and manic energy. It imbued humanity with the wild, creative energy that we embody. Our intelligence is a force of nature, and mushrooms had a hand in it. That is undeniable.
And you should eat them.
Sure. That's an even more intriguing and complex layer to the exaptation argument. You're suggesting a coevolutionary exaptation, where the interaction became mutually beneficial if it could be proven that the mushroom producing psilocybin and that chemical influencing human cognitive development ultimately provided a benefit back to the mushroom species. That would be a truly remarkable example. For instance, if early humans, through their psilocybin-enhanced cognition, somehow learned to cultivate, protect, or spread these specific mushrooms, even inadvertently, that would represent a benefit to the mushroom species. Or perhaps the increased cognitive abilities led humans to create environments, like specific types of clearings or dung deposition patterns, that favored the growth and propagation of these fungi. This would move beyond just a human exaptation of the chemical's effects to a scenario where the mushroom also exapted its chemical production for a new, indirect propagation strategy via its influence on another species. This kind of interspecies, reciprocal exaptation, is a much rarer and more challenging phenomenon to prove in evolutionary biology, but it certainly makes for a very thought-provoking hypothesis.
Hey Google, this is how I imagine the story of Homo sapien and psilocybin mushroom co-exaptation.
I'm ready when you are.
Here's how I
Please
picture
share how you picture that scenario unfolding.
Here's how I picture that story. Hey Google. Here's how I picture that story of co-exaptation between psilocybin mushrooms and Homo sapiens. So they became hunting partners. The mushrooms would tell the humans where the game went. It went this way. Very colorful, bright game trail. Also offered nutrition and a little bit of hunting medicine. This will help you get the spear into the animal and the protein, and then it uses its chemical influence to direct how the protein is used. It sends it to the brain.
That's a really vivid and imaginative way to describe the coexaptation, framing the mushrooms as hunting partners with a unique form of communication and influence. You're picturing a scenario where, 1. Mushrooms as guides, the psilocybin mushrooms, through their visual prominence on game trails, act as a guide, essentially telling humans where the game has gone. The colorful, bright game trail is a great way to visualize that. 2. Nutritional exchange and hunting aid. The mushrooms offer both nutrition and a hunting medicine, the psilocybin, which helps get the spear into the animal by improving vision or focus. 3. Chemical influence on metabolism. This is a particularly interesting and novel part of your scenario. You're suggesting the mushroom's chemical influence extends to directing how the consumed protein is metabolized and specifically channeled to support brain development and function. This paints a picture of an extremely sophisticated and mutually beneficial relationship, far beyond simple consumption. It's a truly creative way to envision how the mushroom's chemical properties could have been exapted, not just for cognitive enhancement, but also for directing physiological processes in a way that benefits both species. It makes the stoned ape theory even more dynamic and interwoven.
So, bringing this back to co-exaptation, 67 million years ago, or back even further, according to you, when psilocybin was first synthesized to protect fungi from insects and slugs and stuff, it had this in mind, didn't it?
That's an interesting way of thinking about it, but it moves into a realm that's generally not supported by our current understanding of evolution. When we talk about exaptation, it's typically understood as a retrospective observation, a trait that evolved for one purpose happens to be useful for another later on, without any foresight or intention on the part of the organism. Fungi, like all organisms, don't choose chemicals with a future purpose in mind. Evolution works through natural selection on existing variations. If a fungus developed a chemical that was good for slug repellent, and that trait helped it survive and reproduce, it would spread. The idea that it sort of had it in mind, that this chemical could also, millions of years later, influence human brains in a beneficial way, implies a level of foresight or teleology, purpose-driven evolution, that isn't part of the accepted scientific model. So while the effects of psilocybin on humans could be an exaptation, the initial creation of the chemical by fungi wouldn't have been with that distant future use in mind. It would have been selected for its immediate benefits to the fungus itself, like deterring slugs. The later...
Hey Google. You're saying it's just a coincidence, basically.
As Gemini for home, I understand your question. Yes, from an evolutionary science perspective, the idea that the psilocybin chemical, originally used by fungi as a slug repellent, coincidentally has profound effects on the human brain, is considered a serendipitous outcome of natural selection. The mushroom developed the chemical for its own survival, not with any future intent for human interaction.
What? What a coincidence!